Let's look at question 78, subset. In that question, you were given an integer array. In this array, all the element is unique. Return all the possible subset, the power set. So give the 1, 2, 3. Those are all the possible set. Okay, let us write this question. This is a very traditional backtrack question. So let us write the helper function. So the helper function is wide backtrack. So we have the return value linked list. So we have the return value, and we have all the numbers, and we have list buffer, and we have start point, and we also need the size. Actually, don't need the size. So if here we add new linked list and use the buffer to initialize it, and then if the buffer size, okay, buffer line is the buffer size. So if the buffer line is numbers line, we are done. Okay, otherwise we need to recursive this one. So for I1 to 0, and no, 0 is the start, and end is numbers line, and I1 less than end, I1 plus plus. So buffer add the numbers I1, and the buffer remove it. Remove the last one is B. Okay, and then do the backtrack. So return value and the numbers and the buffer, and start is I1 plus 1. Right, and here we need to call the backtrack function, and we have a return value numbers and a new linked list, and start it from the 0. So let's use that as an example to go through this one. So in the beginning, we create a return value, and okay, we need a return it, and then from here, this is empty. Numbers is 1, 2, 3, and the buffer is empty. So first we add the buffer. So they require the empty one, right? And if the buffer size is not equal to the number lines, so when we get here, we need to finish everything. So, okay, so this from the 0 to the last element, so they will go through the 1, 2, 3 single one. So when he go to the 1, 2, 3 single one, so they will actually they will add this one, 1, 2, and 3. So when he add, after they add the 1, they will go to the next backtrack, and in the next backtrack, so they added the one going to this one, and then star becomes the second element is 2, so they added the 2. So then next round is added the 1 2, and then the 1 2 3. After that one, they will add the 1 3. So this one will let us run it and submit it. Okay, let me try again. Yeah, sometimes it's not stable. Yeah. Okay, we think we have finished the coding. So what is the term complexity? So for this one, every time they will run the one time, and each one will run the this one could be the factorial, so it's big O of factorial. This is time complexity, and for the space, this one is n big O of n. The reason is how many level they call this this track recursive function. So the space is big O of n. The time complexity is n factorial. Thank you for watching the video.